Okay, here we go. All right. Okay. Can everybody kind of forget about math for a little bit? Is that possible? Or okay. Let's forget about math for a little bit. All right. So let's go. What we did here is I'm going to review for a little bit, and then we're going to play the grid game. All right. So here's a quick review. If you want to understand the structure of the atom and all these vocabulary words, this little brick wall, what I'm really trying to say is learn the world of mass and tell me, without looking, what are the things, what comes to your mind when I say the world of mass in an atom? Give me some words.
More like the mass of like a proton, like
Okay, how much?
one.
Yes, okay, what else? Huh? The nucleus, yes, 99.999% of the mass of the atom's in a nucleus, so we're in the world of nucleus. I need some more words. The world of mass. I know we do better than this. The world of mass, the world of the nucleus. Isotopes.
Chemical symbol.
Yeah, but the chemical symbol comes from what in the nucleus?
Amount of protons.
Yes, number of protons. What's that called, number of protons? Atomic number. See that? Isn't that right? What do you call any particle that's in the nucleus? Nucleon. What are the two types of nucleons?
Protons and neutrons.
Okay. What's the mass of a neutron? One what?
Atomic mass.
Okay, what do you think? Is this coming back a little bit? Okay, so anyway, let's take a look at the world of mass again. And the electron has a mass essentially, it's almost zero, essentially zero. Yes. Oh, that helped. That would help. Thank you. Thank you. Why didn't you say that?
I didn't know that you were doing.
Okay, sorry. Well, actually, you're right. I actually wasn't. You're right. I just now got to the handout sheet. You're right. All right, here we go. On the handout sheet, we know that the electron's mass is essentially zero, and we don't actually include the electron in the world of mass. Now, if you look at a model, and I'm reviewing here, okay? This is supposed to fill in gaps, fill in some gaps. I look in the nucleus, and I see 3 protons. I know that's the atomic number is 3, and the only element that can be atomic number 3 is lithium, and so it has to be lithium. And then I look, I notice there are 3 protons and 4 neutrons, or 7 nucleons, right? 7 things in the nucleus, so the mass number is 7. Okay, and so the symbol, if I wanted to write the symbol for that isotope, I would write Li, and you can put a 3 here, that's the atomic number, and also you have to put the 7. You have to tell me this isotope's mass is 7. Now, if you had one of these that had one less, it only had 3 protons, 3 neutrons, what would you write?
6.
Lithium 6, and that'd be a different isotope. It's still lithium, isn't it? It's still lithium, it's just lithium 6. Okay, then we flip this over, and we notice there are 3 different atoms here, but even though they're 3 different atoms, they're all what element? Hydrogen. And hydrogen only has 3 isotopes. It's the only isotopes I know of that they actually gave names to. The rest of them, they just called them carbon-14, U-235. Kind of boring names, but these had the name of protium, deuterium, and tritium, right? Okay. Anyway, these are isotopes. That's the world of mass. Now we're going to cross over that brick wall. And tell me about the world of charge. What do you think of when you think about the world of charge? Charges, positive, negative. What else? Ions. Electrons. In the world of mass, it was proton, neutrons, right? And what is it in the world of charge? Protons, electrons, right? Isn't that right? What else? Charges. Anions. Anions. Not in the nucleus. You gave me anion, but you didn't give me cation. Okay. Okay, let's take a look. Here, I have 3 protons and 3 electrons. That means I'm an atom. And if I just say the word atom, you're to assume it's neutral. If I don't think it's neutral, I use the word ion. Is that right? Okay, so how do I... where do I put the information about the world of charge?
Top right.
Top right.
Okay, and so what if lithium lost one of its negative electrons?
It become
If
positive.
we, yeah, so, and metals, remember where the metals are?
In the middle.
Metals have a tendency to lose 1, 2, or 3 electrons. They tend to become ions with either a +1, +2, or +3 charge. And so if that lithium did lose one of its electrons, it would have 3 protons and only 2 electrons, and it would have a +1 charge. It would be a cation, a lithium +1 ion. Are you with me on that? Notice that I'm not trying to mesh the world of mass and charge. They're all separate in here. Get that? If you keep them separate, you're going to understand this. Now we go down here, and we see that lithium, before I brought it close to the chlorine, he was just a neutral atom, lithium. There's his symbol right there. And chlorine was just chlorine. It had 17 protons, 17 electrons, just chlorine. But when you bring a metal and a nonmetal together, most of the time, metal and nonmetal together, metals have a tendency to, what do they do? Metals have a tendency to,
Bond.
I'm going to ask you this 100 times this year. Metals have a tendency to lose an electron in a chemical reaction. Nonmetals have a tendency to gain, and that's actually what's going to happen. And when this guy loses a negative electron, he becomes a positive ion, a cation. And what does chlorine become? Chlorine had 17 protons, now he has 18 electrons, so it becomes a -1 ion. And so now, why do they stay together and form the compound lithium chloride?
Ionic bond.
Positive and a negative bond. Like
Okay, ions with opposite charges, or anything with opposite charges, attract each other, don't they?
Yep.
So now for the first time, you know that, what's the name of a bond that holds ions together?
Ionic bond.
That's why they call it an ionic bond. And the nature of ionic bond is not to share electrons at all. We're not sharing anything. I can't get away from you because we have opposite charges. Yes?
Yeah.
Okay, so guess what? What are ionic compounds made of? Starts with an I.
Ion.
Ions. Opposite charge ions, right? What kind of a bond holds an ionic compound together?
Ionic bond.
Okay, and let's see. Oh, here's one more. What word is used in chemistry to describe any ionic compound, which means you have positive and negative ions, or metal and non-metal most of the time? What four-letter word means that, or it's 5 in this case because I pluralize it. What word means you're an ionic compound?
Ions.
No, it's salt. Okay, now, what is the world's most famous salt? Is table salt, known as
Snapple.
sodium chloride, right? Remember that? But even in the ocean, there's at least 15 different kinds of salts that make up the ocean. It just happens that the number 1 salt in the ocean is sodium chloride. But if you go to a store and you want to set up a saltwater tank, you don't have to go to the ocean and get your water. They have this bag. It's called Ocean in a Bag or Instant Ocean or something like that. And you fill up your tank with water, distilled water, and then you pour that in there. And if you look on the back of the package, it'll show you the 14 kinds of salts that are in ocean water salt. So all those are salts. So if I said, what about potassium fluoride? That's a metal and non-metal. That's a salt. And we'll learn more about that when we start naming compounds later. We'll have to know what salts are. Okay. What do you think? All right, let's turn the page. And what I'll do is, let me redo this one because I used the wrong paper. We're going to play this thing called the grid game. And we didn't play the grid game yet, did we?
No.
Okay, so here's what we're going to do. I'm gonna put down a symbol, for example. I'll start out with this one, Na plus 1, 11. I mean, 22, 23, sorry. Okay, sorry. All right, now, let me show you how I think you should play the grid game. And especially when you first start out. Later, some of you will get so good at this, you'll be able to do it all at once. But for right now, I'm going to keep my mind focused on one thing at a time. So the first thing I'm going to do is the thing called the alwayses. And if you become a chemistry professor, you're not going to see this in a book. I made this up. It's called the alwayses. What's always true about this thing? And what I do is I go right to the symbol and I see what?
Positive charge.
No, don't look at that.
Na.
See the Na? Now watch. Na is always what atomic number? That's always true. You can't be fooled in there, right? And the atomic number always tells you how many protons you have. So now I'm going to put a little check mark here because I have finished the alwayses. Now, on my brick wall thing, if I want to do the world of charge first, I can. Or I do the world of mass. It doesn't matter. But do the alwayses first. Okay, ready? Let's do the world of mass. And the world of mass, this isotope, I look over here in this corner, this isotope has a mass of 23. That means that's your mass number, isn't it? Mass number, though, is how many things are in your nucleus. You have 23 things in a nucleus, and 11 are protons.
12 neutrons.
I think I'm done with the world of mass. Am I going too fast?
It's a good pace.
How about the alwayses? You got the alwayses down? Okay, those three things are always locked together. Okay, the symbol, the atomic number, and the number of protons. Okay, now the world of charge. I don't want you to get fooled, but here's how you play it in my mind. There's a little game between the plus and minus. It's like a soccer game if you want to play it that way. And right now, most of the time, if you're a neutral atom, the score is tied, isn't it? If you're a neutral atom, you got the same number of pluses as minuses. But not this one. Not in the case of an ion. Who's ahead? The pluses are ahead by 1. Well, who's positive and who's negative? Okay, and the positives are ahead by 1? Then you must be what?
10.
All right. What do you think?
Good.
Now I'm going to ask you to do something kind of unusual. I have a periodic table up here, so you can look at that, all right? Or you can look up there. But I'm going to ask you to volunteer to come up here. And what I'd like you to do is I kind of want the people who are not 100% sure how to do it. And by the time you get done, you'll say, I feel a lot better about this. Now, for those of you who think you already caught on, I have some for you later. So if you'll hang on, I have some for you. But right now, I don't want people that are 100% sure. So if you are under 80% sure how to play the grid game, raise your hand and you can come up here, okay? All right, you're going to do one?
Yeah, sure.
All right, what I'm going to do is, now this is up to you if you want to, but here's something you can do on your notes. If you happen to have two different colored pencils or pens, here's what you could do. You could, in one color, write down what I gave, and in the other color, what you had to come up with. So if you go home and study the grid game, you'll know what you were given, and you'll know what you had to come up with. But if you don't want to use the two different colored pencils, you can. You don't have to. So I'll leave the orange one here for what you had to come up with, and then, okay, thanks. Okay, I really do. Oh yeah. So anyway, what I'm going to do is write down one here. So let's go with, I think I'll go with this one right here. Okay, so, and that's what I gave, and if you'll go up there and we're going to play this game. Okay. Are you ready?
Do I have to like speak or like?
Go.
Oh, wait. Oh, darn it.
Quick.
I did not tell you all the rules of the grid game. How I forget that? Every year I forget that. The rules of the grid game are you're not allowed to write any number on that paper until you can explain to them how you know that's the number that goes down there. Did I forget to tell you that rule? Anyway, thanks for volunteering, though. All right, I'm ready.
Okay. So the atomic number would be, let's see, the atomic number would be 8. Do you guys agree?
Why? Why is that?
C.
I don't know why.
Because that's what's on the periodic table.
There's lots
And
of
that's the
things.
number.
There's a lot of
the-
things on the periodic table.
That has to deal with the world of mass, and it's the number of protons in oxygen.
How do you know that?
¿Cuántos tienes años?
Because I'm not sure.
All right, so what do you want to put down? Number of protons?
Well, the
Would
atomic number.
you say, the atomic number, what are you going to put, 8?
Yeah.
Okay. Would you say oxygen always has a number, atomic number 8? Always?
Yes.
Are they always?
Always.
Okay, all right, let's go on.
Okay.
And since always the number of protons is the same as the atomic number.
Wait, always?
Always?
Always? Really?
Always.
Even if it's an ion?
Yes.
How about if it's an isotope?
No.
No.
I don't know. You're
It's
tricking
always.
me.
It's always.
He's playing games with you.
Well,
You guys are trying to trick me
well,
too.
no, it's a good game. It's a good
It's
game.
the grid game, buddy.
All right, now what are you gonna do? Now what are you gonna do?
The mass number,
Okay.
which is 18.
Well, is oxygen always have a mass number of 18? Always?
No.
You're right. It doesn't. Does this one have a mass of 18?
Yes.
Oh. Wait,
Oh,
he's
no.
doing it. Wait, he's doing it.
How is he gonna do
Wait,
this?
no. He's doing it. You'll have your chance.
You got this wrong.
Since the mass number is 18, and the number of neutrons, the mass number is the protons and neutrons, so I have to subtract 18 from 8 to find the number of
I think you
neutrons.
mean subtract 8 from 18.
I always get that, yes.
Okay.
Okay, which is 10. So there's 10 neutrons,
Yeah.
and the number.
Wait, are you done with the alwayses? I didn't put a little check mark there, do you?
Oh, yeah. So,
And are you done with the world of mass?
yes,
Okay, so you're doing the world of charge now.
yes.
Okay.
So it is a -2 charge.
Yeah.
So since protons are always positive and there's 8 protons and it's negative, so that means there has to be 10 electrons.
So they'd be ahead by 2, wouldn't they?
Yes.
Okay, so positive 8 and negative 10 would give you -2.
Mhm.
What do you think? Check off your. All right, there we go. Thank you. You did a good job.
Thank you.
All right. Now, again, it sounds unusual, but I really want you to volunteer if you're not sure. Okay, I'm really serious because if you're not sure and you come up here, when you get done, you're going to feel a whole lot better about it. I got one volunteer. Anybody else? All right. Zoe, come on up here. All right.
I'm gonna look on our stage.
Okay, there we go. All right, everybody listen. The best thing you can do right now is listen. What are you going to do, Zoe? When you start out?
The atomic number.
You want to start out with the world of mass?
Yes.
No, I wouldn't. You want to start out with the world of charge?
Yeah.
No, I wouldn't do that either. Wait, relax. So what is it? Hey, wait a minute. Tim can't hear. What is it I think you truly should start out with first? Everybody? What should you start out with first?
Always.
The always is.
Always is.
Okay, let's do the always is first. If you don't do the always is first, you'll get yourself in trouble. All right, here we go, Zoe. And I'm glad you're up here. I'm really glad. What do you want to start with?
Well, on the periodic table, the 9 is the number of protons.
For what? What are you looking at? And how do you know about 9?
'Cause the
Are you looking at the 20, the -1, or the F?
The F,
Yeah. And fluorine, what about? Go ahead, I'm listening.
it has 9 protons.
Always?
Yes.
Always.
Yes.
That's true. All right? What else is part of the always?
The atomic number.
Yes?
And it's the protons and the neutrons, right?
Okay, good question. Let's do atomic number.
Yeah.
Okay, atomic number. What do you know about the atomic number?
It has to do with the.
The atomic number is always the number of protons. So how many protons do you have?
So 9.
Okay? Can everybody listen? Is everybody listening? Everybody listening? Okay, you see what happened there? Okay, now by starting with the always is now it doesn't matter which world you go to now. You can go to world of mass or charge. So which one do you want to do first?
Mass.
Okay. What do you know about the mass?
It's the protons and the neutrons.
Okay,
so
but you don't have neutrons.
Oh yeah, true. The
But look at the symbol. Where would I find information about the world of mass?
over here.
Yes. So this isotope has what mass?
20. Or
Look in that corner again.
20.
No, the symbol. Look at the symbol. Where's the upper left-hand corner?
This.
Yeah. What's the mass of this isotope?
20.
20.
That's what it
That's what
says.
she said.
Oh, I didn't hear. Okay. Where are you going to put it, though?
Over here.
Can you do me a favor? Close that door there. And you don't have to do it. Okay. Now, does fluorine always have a mass of 20?
No.
No.
Huh?
Oh, yeah, I thought that was.
No, no. Okay, but does this one have a mass of 20?
Yes.
Okay. Are you done with the world of mass yet?
No.
Are you done with the alwayses yet?
Yes.
Yes, you are done with the alwayses. You put a little check in that box. What about the world of mass? Are you done with that?
Mm-mm.
Okay, what do you have to do?
The neutrons.
Okay.
So since the mass number is 20 and it's made up of the protons and the neutrons, you'd have to subtract 9 from 20 to get the neutrons. And that
Say it
would,
real loud so everybody can hear you.
and that would give you 11. Right?
Okay. Are you done with the world of mass?
Yes.
Okay.
And then it has a -1 charge, which means that there's one more electron than protons.
Yes.
And there are 9 protons, so 10 electrons.
Yep.
Yes. Very good. All right. Good. All right. I want somebody who's not sure. Okay. Mallory, come on up here. Do you feel a little better?
Yeah.
Would you tell Mallory that you feel better when you get done, right? So you want to volunteer. You want to volunteer. All right. Let's see here.
Billion.
Um,
Billion. Oh, he's doing it. He's switching it up, Mallory. Don't get nervous.
Doing the gritty game.
yeah. Did I forget to tell you that there's another way of playing a grid game?
Yeah, you forgot.
Okay.
Yeah.
But there's another way. There's another way to play the grid game is where I give you some numbers, and it's just enough numbers to be able to figure everything out. But you know what? If you can get through this one, you're going to feel really, really good, and you are going to get through this one.
Yes.
All right. So let's think about it. Everybody, listen carefully.
So the number of protons is the same as the atomic number.
Wait, always? Always though?
No, yes.
Huh?
Yes.
That's true. It is always. It's always true.
Okay, so
And
and then
And there's one more thing that's linked to an always. What is that?
the
Ask somebody in the audience, see if they.
Lily.
The atomic number is always connected to the number, to the element.
Oh, yeah.
The symbol. It's the chemical symbol.
So then the symbol is hydrogen.
Okay, huh? Can I put a little, get rid of that one. Who told you to
Oh
put
wait,
that
not the
in?
one. 2.
You can't erase
That would
that.
be it.
No, don't do that. No, we're gonna do the alwayses first. Now put a little check box on the always. You wanna make sure the always is done. Now what world you look like you're really anxious to get in the world of math. Let's go ahead and get in the world of math.
Okay. So the mass number is 2.
Okay, put that there.
And you can do the mass number minus the number of protons and get the number of neutrons. So that would be 0.
What?
0 neutrons?
So what number are you subtracting?
The mass number.
Minus what?
Oh, that would be 1.
Okay. Are you done with the world of mass now?
Yes.
Okay. What about the world of charge?
Would you do? Wait. So the protons. There's 1 proton and 1 electron. So would it be?
Say that again.
There's 1 proton and 0 electrons.
Okay, that makes a difference. Okay, fine.
And so would the charge be?
So if I was your math
Would it be-
teacher and I say +1 plus 0,
That's just 1.
okay?
So is that?
So where
it
do you
would
put
just be plus
that?
1. Right here.
Uh-huh. What do you think? What do you think? That's it. Very good. You feel a little bit better?
Yes.
All right. All right, thank you. Good job. Next. Who's not 100% sure? Maybe you're 80 or something like that. I'm gonna save one for you. All right, Tim, come up here. Okay. All right, here we go. The most important thing right now is listening, okay? That's what I'm doing. I'm listening to everything they say to see if I can catch a mistake.
All right, 235. That's a lot.
But what do you want to do first?
Find where.
Wait, you want to do the world of mass first?
Yeah,
I wouldn't do that.
I wouldn't know. Yeah.
How about the world of charge, though?
That's yeah.
No, I wouldn't do that either.
Oh
What is it? Wait, what is it that I think you should do first? Honestly,
World of the always things.
The always
The
things,
always
yes.
things.
and I really, if you do always is first, you'll be less likely to make a mistake. All right. So what about always is?
So, the number of protons is always the same as the atomic number.
Well, I don't know the atomic number.
That's true. You don't know the mass number.
Well, no,
I don't.
not the world of mass.
No, that's the world of mass.
I'll give you a clue. Don't look at the 235. Don't look at the -2. Just look at the U. What do you know about U?
U is an element that is uranium, I think. Yeah. And it's 92.
92 what?
Atomic number.
Okay. Is uranium always 92 though?
Yes.
Always? Don't look at anybody. Always?
Yes. Always.
That's true.
You can't phase me, Daniel.
All right, here we go.
And the number of protons is always the same as the atomic number.
Okay. All right. Now you can check off the always box. Now, which world do you like to get into?
The world of mass.
Okay.
And so the mass number is 235.
Always for uranium?
No.
That's right. Does this one have a mass of 235?
Yes.
Okay. You done with the world of mass? You done with the world of mass?
Yes.
No?
No. No, I'm not. And the number of electrons.
Wait.
Oh,
We don't say the word electrons in the world of mass.
do we say neutron?
Yeah.
So we have 90.
What does mass number mean?
Mass number is like how much it weighs.
Yeah, but where's the weight? Where's that come from? Where's that mass come from?
The periodic table elements.
Yeah, but what is it that gives us mass 99.999% of its mass?
Nucleus.
And what's in the nucleus?
Atoms.
No.
No. Neutrons.
And
Protons and electrons.
no.
Oh!
It's okay. Wait. Wait. It's important. If you wait a minute. Everybody stop.
They're throwing me off.
Okay. Only protons and neutrons are in the nucleus. Okay?
Right, electrons are outside.
All right. So anyway, So the number of protons plus neutrons is a mass number.
Right. So it's like, isn't it? Oh, neutrons plus protons is mass number.
Right.
So it's like, if I do a little bit of math there,
143.
143.
I'm really glad you came up though. This is going to help you.
Yeah. And number of
Are you
electrons.
done with the world of mass now?
Yes.
Okay.
And the number of electrons is 94.
How do you know that?
Because it's -2, so it's 2 less than.
2 less than 92?
No, it's 2 more negative things than protons.
Right. The negatives are ahead by 2, aren't they?
Right.
And you have 92 positives.
Right.
That's it. That's it.
I
Good
feel,
job.
I feel better.
Yeah. Hey, you need the pen there. Thank you.
Oh, sorry.
All right. What do you think?
Good job, Timmy.
All right. Now,
Can I go?
you already went. Hang on. All right. So, how about somebody who feels like they're pretty confident? Oh, I like
Daniel, put
that.
Daniel up there.
1, 2, 3, 4, 5. I don't have 5 left. Let's see. Darn it. Who can help? Dang. Who did I pick? Hey, pick somebody for me, right? Zach, pick somebody.
Pick someone?
Yeah. Don't forget. Hey, Daniel. No, just pick.
Will.
Okay, Will, come on up here.
Dude. Oh, you're getting.
Okay, Will.
Oh shoot. What is that?
Only a proton.
Yeah, that's right. All right, here we go. Here we go.
Only a proton. I guess I mean is that the number of protons is 1,
Uh-huh.
and that makes the atomic number 1. Based on that, hydrogen is the atomic number.
Have you finished the always is now?
Yeah,
Everybody quiet.
and then
Yeah, I gotta listen.
the mass number could be like infinity or something because you don't know the number of
So
neutrons.
what are you gonna do? How are you gonna finish this? You don't?
Yeah.
What do you have? What's given to you?
The hydrogen and the.
No, what's given to you?
Oh, only a proton.
Only, that's all right.
Oh, so then
That's
there's
all?
0 neutrons. I mean, 0 neutrons and 0. And then the charge is +1.
What do you have?
There's 0 and 0.
I think the mass is.
No, yeah, the mass is just 1. Yeah,
Well.
my bad.
Haha.
Okay, now, are you done with the world of mass yet?
Yeah.
No? Look at this symbol.
Oh yeah, you have to put it, the mass up there.
Okay, let's do it.
1.
Are you done with the world of mass?
Yeah.
All right, a little check mark. Are you done with the world of charge? Everybody listen.
Yes.
Listen.
It's 0.
No, you're not done. Look
Oh,
at
you
the
have to
symbol.
put the symbol, yeah, which would be +1.
All right, that was a difficult one, wasn't it? And I wanted to pick somebody who said they felt pretty good, but even if you felt pretty good, you still have some things to learn, right? All right, somebody else. Okay. I said I'd save one for you. I'll have one for you too, all right? Ready? All right, come on up here. Okay, Rutherford, he had this radioactive material, and that means part of the nucleus of those elements were actually disintegrating, and they would give off these things called alpha particles. And the thing in his experiment that he was firing out of that lead box were alpha particles. And alpha particles are made of 2 protons and 2 neutrons, and that's all. And so they were positively charged bullets. All right, here we go. Alpha particle.
Right here?
Mm-hmm.
Okay. And this is what I get?
Yeah, 2 protons, 2 neutrons.
So basically, see 2 protons, and you get the atomic number from the amount of protons. So since there's 2 protons, it has to be helium for the symbol.
Sure.
I'm positive.
Is it always helium?
It's always
For 2 protons.
for 2 protons. And then the atomic number for helium is 2. And because you know the atomic number is always the same as the number of protons, so that's also 2.
Okay. You know what the always is?
Yes.
Okay. What world do you want to get into now?
I'm just gonna do the neutrons because I can see them right there.
Okay.
So those 2 circles are the neutrons. So say 2 neutrons. Now I'm gonna get into the world of mass. See, so the mass number is the number of protons plus the number of neutrons.
Okay.
So it's 4. And
The
now,
world of mass?
no. You have to put it up here.
Very good.
And then now we go into the electrons. And for the electrons, you do the mass number.
No.
No.
Yeah, when you talk about electrons, let's not talk about mass.
That's wrong.
Not wrong. He's going to catch himself.
Yeah.
Look at what I gave you.
Mm-hmm.
So how many electrons?
How many? 0.
Okay.
And then because there's 2 protons, 0 electrons is plus 2 charge.
Very good. So what was becoming away, these radioactive elements were giving away part of themselves, 2 protons, 2 neutrons. It's the same as the nucleus of what element? Alpha particles the same as the nucleus of what element?
Helium.
Helium. Kind of interesting. Okay. All right. Time for one more, okay? Okay, here we go. I said I was going to say one for you. Okay, so here we go. But I got to think of a good one. Wait a minute. Hang on. Okay, I'm ready. All right, here we go. This is the last one, and I think she can do it in 30 seconds. Let's see if she can do it in 30 seconds.
Oh, I don't know if I can do that.
All right. Hold it.
Okay.
You can do it.
So, since the mass number
Uh-huh.
is 40 and the neutrons are 20, then the protons are 20.
Okay.
And since the protons are 20, then the atomic number is 20.
Okay.
And on the periodic table, 20 is calcium.
Okay.
And since there's positive 2, so then there's 2 less electrons. So that would be 18.
Wow, you did it in less than 30 seconds. Very good.
And then this would be 40.
Very good. Wow, that's great. All right, one more time. The quiz on Monday has a lot more to do with the history, so make sure you look at each scientist and what they did. And then you'll also see some questions like the mini grid game. I have a lot more of the grid game on the real test, okay? So you'll have a chance to show off on that one. Hey, good job. Good job. Have a nice weekend. Have a nice weekend.
Oh no.